Hello everyone, in this video we will derive the surface area of a cone. This will be purely a mathematical derivation, no cutting, squashing and reimagining the cone because, you know, honestly some of us are just not good at that. So let's get right into it. So first let's draw our cone. So imagine, again, I think you already know what a cone is. So it's a circular kind of shape with like a triangular slanting anatomy, and you can imagine it's made of multiple circles inside of it. And let's label our cone having a radius of r, a height of capital H, right, and a slant height over here of L, right? We label this as L, and obviously by Pythagorean theorem we know that L squared is equal to r squared plus h squared. We'll use this later on. So what is actually the surface area of a cone? So depending on the type of problem you're dealing with, there might be different variations, right? So the is the base, the bottom of the cone, is this a surface? Sometimes it might be, sometimes it might not, but for this video, let's say it is, right? So you have the surface at the bottom of the cone, and then you have this surface along the sides of the cone, right? Like the surface, like, yeah, along the surface or the side of the cone from the bottom all the way up top, right? So basically we'll have the total surface area equal to pi r squared, because that's the area of a circle at the bottom, plus the surface area of this sides of the cone, right? And the way we'll derive it is again similar to the surface of area of the sphere video, where we break it down into multiple circles, right? Uh, and for each circle, we'll have some sort of radius like r sub c, right? And we'll integrate that. We'll take that circle's circumference and multiply it by the minimal height over here, which is dl, right? Because the surface is along the L axis, right? It's along this slanting axis. So we take these very little circles with a circumference and multiply that by dl to get the surface area that they cover, right? Because the circumference times this minuscule height will be like an area, like you can imagine like a strip across the surface of the cone, right? Whose height is dl, and we'll integrate all these small strips to get our uber surface area. So it'll be basically the integral from 0 to L, right, of the area of this circle will be pi r sub c, right? So this radius over here, which is the radius at any arbitrary length L, and then dl, because we're integrating across the L axis. So to proceed with this integral, we need to express r sub c in terms of L. So let's do that. We'll draw a little triangle here, and we'll let this top be equal to height 0 and the bottom be equal to height h, right? Or the top be equal to L0 and the bottom be equal to L equals capital L, right? So for any partial L over here, which is small letter L, and any r sub c over here, which we're going to integrate, right? How do we compute r sub c in terms of L? So we know that this angle is constant, right? This theta over here is constant, and we know that this is r because this is the center to the edge of the cone at the base, right? So this is r, this is r sub c. So since the theta is equal, we know that the sine theta, which is opposite over hypotenuse, is the same, right? So the small triangle here, opposite over hypotenuse, is r sub c over L, and in the big triangle, our sine theta is capital R over capital L, right? So that's over here. So if we express r sub c in terms of L, we'll have capital R over L, which is the radius and the slant uh, dimension of the cone times L, which is cross multiplied over here. So now we'll plug this into our integral. So again, we'll have surface area here pi r squared, which is just this part. Oh, this should be 2 pi r, right? Because it's the circumference of the circle is 2 pi r, right? So it's 2 pi r plus, so this integral substituting r sub c, right? And so the next step, continuing to solve this, so we have pi r squared. And now let's actually carry out the integral. So we have the constants, which is 2 pi r over L, and then integral of L dl is just L squared over 2, and we evaluate this from 0 to L. Okay, and this is plus over here, right? Because that's the term from here. So again, simplifying this, we have pi r squared, and then we substitute L into the small letter L. So the 2's will cancel, right? Because there's 2's here and 2 here. So this will become pi r, and substituting capital L over here, we'll get L squared over L, which is just L. So it will become pi r L. And if we substitute 0, it's just 0, right? So again, this is plus, and so we'll be left with just pi r L. And so if you rewrite this in other words, it's going to become pi r times r plus L, right? And r plus L can also be written as pi r times r plus square root of r squared plus 8 squared. So if we strictly want the formula to be in terms of r and h, you can do this. Or if you want the formula, if you're okay with the formula having an L in it, then you can do this. And obviously, if the base is not included, then you just subtract pi r squared from this expression. So it's just going to be pi r L or pi r times this expression over here. So yeah, that's the surface area of a cone, and I hope you enjoy this video. I'll see you in the next one. Cheers.